Okay, section 4.2. These are the two things. The first video will probably just do the first one, and the second will do concentrations. So these are part-to-part ratios, part-to-part and part-to-whole. The most common interpretation of a percentage is a part-to-whole ratio. Like, for instance, you spend 17% of your monthly budget on your car. The monthly budget would be a whole, and your car would be a part. In fact, many people define percentages as part to whole, which can cause confusion with dealing with other percentages. These percentages here, we're going to do part to part and make part to whole and see the difference. If we're given the ratio of boys to girls is 2 to 3, 2 boys for every 3 girls, then it can be easily mistaken to say the boys are 66.7% of the class. That's not true, because you don't know, you're dealing boys to girls, not boys to class. Or even worse, 66.7% of girls are boys. The correct statement uses the size of each part. The number of boys is 66.7% of the number of girls. Right? So these ratios here are all the same. 2 boys to 3 girls is the same thing as 66.7 boys to 100 girls is the same thing as 40 boys to 60 girls. We can add the parts to get the whole. So in other words, if we add 2 on this ratio, 2 to 3, if we add the 2 and the 3, we get the 5. So we get 5 students. Add the boys and the girls together, you get 5 students. And this one, add the boys and the girls together, and you get 40 plus 60 is 100 students. All right? And this always works. And I'm going to give you another example of this in a minute. So now you can say there's 2 boys for every 3 girls in the class. You can say there's 66.7 boys for every 100 girls. So the number of boys is 66.7% the number of girls. And you can also say there's 40 boys for every 100 students. The boys are 40% of the class. So using this, that was pretty simple, right? But let's use this and get the same. We're going to get the same percentage that the boys, using 2, 3, and 5, which this is just the sum. So this is 2 boys for every 5 students using this ratio. So I'm going to put that as some number over 100, cross multiply and divide, and you see you get 40%. So we'll look at one more example. There's a forest in Maine. And all these trees, right? And forests have 2 kinds of trees. There's hardwood trees. That's the definition of a hardwood tree. And that particular hardwood tree is a white oak, which they use a lot for boat building in Maine. And then there's also softwood trees. The definition of softwood trees, you know, those is all kinds of different pine trees. So it says a typical acre in a Maine forest has approximately 542 hardwood and 848 softwood trees. What percent of the trees in a Maine forest are hardwood? Okay. This is really the same problem as 2 boys to 3 girls. Right? So this is what you can't do. So there's what you can't do. Yes, you can make a ratio of hardwoods to softwoods, but then if you're trying to find out how many hardwoods there are, the percent, you got to know the total trees, and we don't know the total trees. So this is an absurd proportion. It doesn't make any sense. It'd be like dollars to ounces as trees to bananas. So you got to have hardwood, softwoods, hardwood, softwoods. So that simply will not work. So what we're going to do here is just take the 542 and add it to the 848. And we're going to get 1390. Oops, here we go. 1390 trees. So that's the total, because there's only two kinds of trees, either hardwood or softwood. It's like there's only two kinds of students, either boys or girls. So if you add boys and girls, you get students. You add hardwoods and softwoods, you get trees. So now I have a total here. And now I can establish a ratio per 100. So let me put it up there. So there's the math. Now I got 1390 trees. I can go hardwoods to trees equals some amount of hardwoods to 100 trees to get 8%. So I'm just rescaling this. These two ratios will be the same. And obviously I'm not going to go through the cross, multiply, and divide. You know how to do that, hopefully. And it comes out to x is 40. So that goes here like this. And wind up with 40, that's 40%. So 40% of the trees in Maine forest are hardwood. Now the last question, hopefully I don't even have to answer. So what percent of the trees are softwood? And it's going to be 60% because the hardwoods plus the softwoods will add up to 100%. Okay, so we're returning to our Maine forests. And we're going to look at two types of trees. Birch trees and maple trees. So it says that a Maine forest, I don't know if that's spelled right. Oh, they want a comma. In a Maine forest, there's approximately 21 birch trees for every 38 maple trees. So if I ask you a question like that, and leave these blanks here, we'll talk about how to fill those in. So there's how many birch trees for every 100 maple trees, and the number of birch trees is what percent the number of maple trees. Now, I really can't add up birch trees and maple trees and get total trees in the forest because there's all kinds of different trees. But just looking at the relationship between this part-to-part ratio about two separate species in a forest. So how do you think you would do this? If I were you, I'd hit pause and think about it. So there's the key to setting up to answer these questions. I've got a percent here, I've got 100 here. So percent is part of 100. So what I'm going to do is birch to maple, cross multiply and divide, and I'm going to get 55.3 rounded to 1 decimal. And that's what x equals. So we could say, move that, x is 55.3, and we can say that so there is about 55 birch trees for every 100 maple trees. And the other way we can say it is the number of birch trees is 55.3% the number of maple trees. So that's dealing with the part-to-part ratio.